Hi guys, welcome back to my channel. What we're going to be doing today is a few fun physics experiments.
Welcome to physics.
Holy mother! Because in my physics class, our last project that we have is a physics video. For the first experiment, I am going to be calculating the velocity of myself if I were to jump out of our classroom window.
In a safe way, of course. You know.
But yeah, so in order to do that, we're going to need to know a few things. We're going to need to know acceleration due to gravity, which would be 9.8 meters per second. Then we're going to need to know the time of the free-falling object, how long it's falling for. And so the equation for that would be v equals gt, where v represents velocity. Okay, so... Oh my god! Oh jeez! Oh my god! Oh jeez! As you see, we have our equation here, which is v equals gt. So, for instance, acceleration due to gravity would be 9.8 meters per second. And then the time that I'm falling out of the window. So, let's pick an amount of time. Let's say 2 seconds. Alright, so let's plug in 2 seconds here. Then, you know, I don't have a calculator, but you do 9.8 times 2. So let's do that out this way, because I don't know how to do that in my head. So my velocity would be 19.6 meters per second. Now you might be asking yourself, if we're doing a problem where we're calculating the velocity of an object falling, wouldn't we need the height? Well, the answer to that question is you wouldn't actually need the height unless you want to know how long it would take for the object to hit the ground, in which then the height would be important. So, now let's do a problem involving height. We need to calculate the height of the classroom, how high it is off the ground. So quick update, Mr. Walker just decided he was gonna leave his tape measurer at home today. I don't know why he ever thought that would be okay. Every time I step up in the building, everybody hands go up. All the way down, that's about 90 meters. We're gonna use that. Okay, so now we're going to calculate how long it would take me to hit the ground when I jump out of the window. So we have h here, which equals our height. And then the rest of the equation is still the same with gt. You're adding a half and a square. I don't know why, but that doesn't matter. So anyways, so for our height, like I said, we are 90 meters off the ground. I think that that's wrong, but I'm putting it down anyways. Then we have 1/2. This is acceleration due to gravity, so we still have our 9.8 meters per second. And then time squared. That's what we're solving for. So we're just gonna plug that in, time squared. So now if you take 1/2 of 9.8, you have...
Anyone?
If we do 1/2 times 9.8, we have 4.9 t squared. Then we're going to divide 90 by 4.9. If my assistant would please do that, that would be great. When we do this out, we get a really big number. So we're going to leave it at 18.37 equals t squared. So now what do you do when you have a square thing, a squared thing? You're gonna take the square root of both sides. So basically if we round that up, it would be 4.3 seconds for me to hit the ground if I jumped out the window. Alright guys, that's all for today. So thank you guys so much.
Yeah. Way up.
Psych, it's a collab.
Okay guys, so now that we learned about velocity, I'm going to teach us about, Newton's laws. I'm going to start it off with the first law, my favorite law by far. It says, an object at rest stays at rest, and an object in motion stays in motion until an unbalanced force acts on the object.
Kenza, the object at rest, is acted upon by Ari, the external force. The collision between Ari and Kenza causes Kenza to sway to one side, accelerating to the left. If Ari had not acted upon Kenza, she would have remained at rest.
Alright guys, so now we're going to be learning about Newton's second law. Newton's second law says that acceleration is proportional to the force on an object and inversely proportional to the mass of an object. And you might be thinking to yourself, what does that mean? You know what? I'm going to show you.
Meg is the object and Kenza is the force acting upon her. Meg's acceleration is directly proportional to the magnitude of the net force applied on her by Kenza. Meg accelerates in the same direction as the force Kenza is exerting, and when she collides with the object on the floor, she bounces back.
Now we have Newton's third law. So Newton's third law basically says that for every action, there's going to be an equal and opposite reaction. So for example, if one body exerts a force on a second body, the first body also undergoes a force of the same strength, but in the opposite direction.
Whoa there!
Kenza and Ari are attracted to one another with an equal and opposite force. Regardless of any difference in mass between Ari and Kenza, they have the same gravitational force towards each other, which causes them to bounce back in opposite directions when they collide, proving Newton's third law of motion.
So undergoes. So what we're gonna be doing?
To do. 4.5. Oh wait.
So today I'm gonna be doing some fun little physics.
So quick backstory on that. Like, we are still friends, even though we spell our names differently, because her H, she would be naked without it, and I would be suffocated with an H, so it just really works out.
That's rude.
Oh, and I just want to shout out one of my favorite people in this whole world. Let me just come over. My queen herself, Kenza. And
She was coming over to me, actually.
Yes, and then this is just my other queen, Ari. She's like kind of more of like a princess. Ow! Oh my god, that just hit me in the ankle. Don't touch my marker, Tanya.
Just as I thought. At the end. Trash.
I know the exact video. It's the same lady that goes.
Just as I thought.